So today we're going to do exercise 33 from the paper 1-3 from May-June 2021, the Yale S-level physics exam from Cambridge. And it says a wire has a length of 12 centimeters and contains a total of 5.1 times 10 to the power 22 free electrons. When a potential difference is applied across the end of the wire, the free electrons move with an average drift speed of 4.0 times 10 to the power minus 6 meters per second. What is the current of the wire? So everyone who tries this exercise understands that normally we have to use this formula. Okay, but we have to understand what each of these things means. Especially the N is the number of charges per unit of volume. Okay, so now we're going to be, we are given 5.1 times 10 to the power 22, not per unit of volume, in total. So if this is the piece of cable, all those electrons over there are N, capital N equals 5.1 times 10 to the power 22. And N in the formula is N divided by volume. So I'm going to use that. I'm going to write N divided by volume, Q, and we don't have the area. But we're going to express the area as the volume divided by the distance. Okay, because if the volume of this cable would be the cross-sectional area times this distance. Okay, so I'm going to express that area as the volume, total volume divided by the distance, and the drift velocity. Okay, so as you see, we can cancel the volume, and now we have that the intensity or current equals the number of charges times E is the charge of the electron, okay, divided by the length times the drift velocity. And we have all of these. So this is 5.1 times 10 to the power of 22. We have 5.1 times 10 to the power of 22 times the charge of the electron, which is 1.6 times 10 to the power of minus 19, times the drift velocity, which is 4 times 10 to the power of minus 6, divided by the distance, which the length, which is in centimeters, so we change it to meters, which is 0.12. And then when you're calculating this in the calculator, I recommend an excess of parentheses, because you might get it wrong very easily. I get a lot of students who get this wrong. And I use a parenthesis here, and a parenthesis here, and a parenthesis here, and I calculate this, and then I calculate the rest, okay? So be careful with that, because it's very common when people get a wrong result in the calculator just because they're not using, the calculator is not calculating what they want. So, and that is 0.272 amps. So the correct solution would be C, which is the one that the marking scheme gives us. So it's correct.